Here's our third system. I look at the system and realize the easiest thing for me to do is to eliminate y first, just because of the nature of the coefficients on y in all three of the equations. So I see that if I use equation A and C, I simply need to add them together. So here's equation A, here's equation C. I'm going to simply add those together to get an equation D. So 5x, x plus 4x is 5x. The y's cancel out. Negative 3z plus 13z is positive 10z. 5 plus 10 is 15. I'm going to eliminate y again, making sure to include equation B. I've used A and C here, and I just have to bring in the third equation, which is equation B, that I haven't used. It's listed as the second equation, but I haven't used it yet. So I'm going to eliminate at y again, and I have to make sure, so I must use equation B since I haven't used it yet. And I see that if I add B and C, I don't have to use any multipliers at all. So if I can avoid multiplying, I certainly want to. And I just want to make sure I copy the equations correctly. Add those two equations together, and that's going to give me equation E. And I get 6x. My y terms cancel out since they're opposites. Plus 12z. Negative z plus 13z is positive 12z equals 18. So I'm going to, in my third step, I'm going to choose to eliminate either x or z. And I'm going to be using D and E to make this happen. All right, now I notice that I have a 5x in equation D and a 6x in equation E. So I am going to have to multiply them both by something. So I'm going to use the coefficient of equation D times E and the coefficient of the x in equation E times D. Since they both have the same sign to start with, one of these needs to be negative. So I'll make the 5 negative. 6 times equation D is 30x plus 60z equals 90. Negative 5 times equation E is negative 30x minus 60z equal negative 90. So when I do this, I find that I not only eliminate x, but I also eliminate z. And I wind up on the left side of the equals with a 0, and the same is also on the right side of the equals. So I have involved all three equations. D was derived from A and C. E was derived from B and C. The variables drop out. I get a true equation. So I know that the system is dependent. This means that there are infinitely many solutions. I have to find out what solutions look like, though. It doesn't mean every single point is a solution in the three-dimensional plane, but it means that I can't count the solutions, but it doesn't mean any and everything is a solution. I am going to be able, because of the nature of equation D and E, I am going to be able to describe the solutions in terms of Z. So I'm going to go to equation D. 5x plus 10z equals 15. And I am going to solve this for x in terms of z. So I'm going to subtract 10z from both sides of the equation. So I wind up with 5x equals 15 minus 10z. And now I'm going to divide each term of the equation by 5 so that I isolate x because I'm solving for x. X equals 3 minus 2z. 15 over 5 is 3. 10z, negative 10z divided by 5 is negative 2z. Okay, so that is what I obtain from equation D. Now, I can go back and look at my original equations, A, B, and C, and I'm going to need to solve for y, and I want that in terms of z. I'm going to use equation A, x plus y minus 3z equals 5. And I'm going to solve for y. And I'm also going to use x equals 3 minus 2z in that equation. So the equation again is x plus y minus 3z equals 5. So I am going to replace x with 3 minus 2z. And once I do that, I now want to solve for y. So minus 2z minus 3z is minus 5z. So I am going to subtract 3 from both sides of the equation, and I'm going to add a 5z to both sides of the equation. Now on the left side, that simply leaves me with y. On the right side, 5 minus 3 is 2, and then I add this 5z. So I now have my solution set. All of my solutions will take this form. They're going to be the collection of ordered triples where x is 3 minus 2z. Y is 2 plus 5z. And z is simply z, which I'm able to choose freely. But once I choose z, then x and y are determined by that choice of z. So this system is dependent, and a dependent system always has infinitely many solutions, and the solution set in this case can be described in terms of z. Sometimes when all three equations represent the same plane, then the solution set is described using one of the equations. In this case, not all three equations represent the same plane, so I'm able to describe the solution set in terms of z. Our fourth system is going to come from an application problem. Evan was in charge of ordering office supplies for the math department. He ordered tablets, pens, whiteboard erasers, a total of 45 items. Each tablet costs $3, pens cost $2, and each eraser costs $4, bringing the order to a total of $146. The sum of the number of pens and erasers ordered is 3 less than 3 times the number of tablets ordered. Determine the number of each item that was ordered. So we want to solve this by writing a linear system of 3 linear equations and 3 variables to represent the problem. We want to label our equations A, B, and C, clearly show our work used to solve the system, and give a complete sentence as our final answer. The first thing that I recommend doing is making sure you're clear on what your variables represent. So I am going to let X be one place that I can get a clue is to look at what I'm being asked to find. So I'm being asked to determine the number of each item that was ordered. So I'm going to let X equal the number of tablets. I'm going to let Y equal the number of pens, and I'm going to let Z equal the number of erasers. So a lot of times if you're not clear on what your variables represent, you can struggle actually writing the equation. Now, one important piece of information is that he ordered a total of 45 items. So that means the number of pens added to the number of the number of tablets added to the number of pens added to the number of erasers equals 45. Then I'm told that each tablet costs $3, pens cost $2 each, erasers are $4 each, and the total value of the order is $146. So that $146, part of that money came from pens. 3x of those dollars came from ordering tablets, tablets. X represents the number of tablets. So 3x of the $146 is from tablets. 2y of the $146 is from pens. And then 4z of the $146 comes from the cost of the erasers. And then the sum of the number of pens and erasers. So that's y plus z. The sum of the number of pens and the number of erasers. Sum means to add. Is 3 less than, so is equals, 3 less than means subtract 3. 3 less than 3 times the number of tablets ordered. So 3 less than 3x. So those are my 3 equations, and that's how they are obtained. Equation A is already in the form I need it to be in. So is equation B. Equation C, I need to subtract 3x from both sides to get negative 3x plus y plus z equals negative 3. So on equation B here, I'm subtracting a 3x from both sides of the equation. And this is how I'm getting equation C. So now I simply need to determine what I'm going to eliminate. And in this problem, it's just as easy to eliminate x as it is to eliminate y, as it is to eliminate z. I'm going to choose to eliminate x simply because right off the bat I see if I use b and c, I don't need a multiplier, and I can simply add b and c, and that will result in the elimination of x. So that's why I'm going to choose to eliminate x first. Someone else may choose to eliminate y first. Another person may choose to eliminate z first. The choice is really yours. All right. So when I add the x terms, I get 0. Those cancel out. 2y plus y is 3y. 4z plus z is 5z. 146 minus 3 is 143. So that's equation D. Now so that was my first step. My second step is to eliminate x again, and I'm going to have to make sure that I use equation A since I haven't used that yet. I notice that the coefficient of x in equation A is 1, and I've got a negative 3x in equation C. So if I multiply equation A by 3, I will eliminate x. When I add that equation to C. So the x terms are opposites and cancel out, and I'm left with 4y plus 4z equals 132. And that's equation E. So I am going to multiply, I'm going to use in my third step, I'm going to use equations D and E to eliminate y or z. I have to choose which one I'm going to eliminate. And I'm going to choose to eliminate y. It's just as easy to eliminate z. Now I'm going to use negative, since the coefficient of y in E is 4 and the coefficient of y in D is 3, I'm going to multiply negative 4 times D. So I use the coefficient in E times negative, the coefficient of E times D, and the coefficient of D, which is 3, times E. So I get negative 12y minus 20z equals negative 572. Then I'm going to multiply 3 times equation E. So I get 12y plus 12z equals 396. So these constants add to negative 176. The opposite y terms cancel each other out, and I have a negative 8z. And I'm going to divide both sides of this by negative 8. And I get 22. So z is 22. And now that I have Z, I can use equation D or E. I'm going to use D. I could have used either one, but I'm going to, so I can use D or E, and Z equal 22 to find Y. 3 times Y plus 5 times 22 equals 143. 3Y plus 110 equals 143. Subtract 110 from both sides. 3y is 33. Divide both sides by 3. And I find y is 11. And now I simply need to find my x. In that first equation, x plus y plus z equal 45 is going to be my easiest one to use. So that's equation A. So I'm going to use A, and I really could use B or C. Y equal 11, Z equal 22 to find X. So X plus 11 plus 22 is 45. X plus 33 is 45. If I subtract 33 from both sides, X is 12. And I can give my complete sentence answer. Evan ordered 12 tablets, 11 pens, and 22 erasers. And that would be my final answer on that one.